Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today we'll be solving the problem n queens. So the problem statement says that the n queens puzzle is the problem placing of n queens on an n cross n chessboard such that no two queens attack each other. Given an integer n, return all distinct solutions to the n queens puzzle and we may return the answer in any order. So we can see we are just given an integer n, and what we have to do, we have to consider a hypothetical n cross n chessboard and we have to place n queens on that chessboard. All right, and we have to fill the chessboard by placing n queens on it, and we have to return the possible chessboards which can form after placing n queens. So let's say we find in this chessboard, this is n is given 4, so we have to draw a 4 cross 4 chessboard, and then we have to place 4 queens there. So we can see that we all know that what is a how queens are placed on a chessboard. So we all know that if this chessboard is given and this is a queen, so if queen is placed here, so no other queen or no other uh, piece can be placed in the same row, in the same column, or also not in the same diagonal, because this queen can attack in 8 directions. All right, so it can attack in 8 directions: up, down, left, right, and diagonally above and diagonally downwards. So it can attack in all the 8 directions. So we have to place another queen such a way that the other queen does not come in the attack range of the first queen. So like in this the second queen which we have placed here, is we can see that it is not coming in the attack range of the first queen. It is safe. So we have to place all the n queens on the chessboard such that the queens are all the n queens are safe. So we can see we have found a first way, and similarly we have found a second way to place the n queens. So we have to return answer, but we have to return answer in a vector of a string. So a board basically here is represented by vector of strings. So in the first solution we can see that this is empty, so we just have to store all the rows in a string form. So basically a board will contain n strings, it will contain n strings, and every string will be of size n. All right, so we can see in the first row, this row if I fill, so it will be filled with, first if there is nothing placed we will write here dot, and if queen is placed we will write here q. All right, and then dot dot. Similarly here in the second row, dot dot dot, and then queen is there. Third row, queen is there, then dot dot dot. In the fourth row, dot dot, queen and dot. So we have to return this answer, and we will just store this in a data structure vector. And similarly another possible board we have to create, and we will just store this into this vector, and we will return the vector. So I hope you understood the problem statement. So now how we can solve this? So let's say I'm taking n is equals to 4. So let's say I have this chessboard n is equals to 4. Now what I will do, the basic thing which we can think of. we can try all the possibilities by placing first queen. So we have total here n is equals to 4. So we have total 4 queens and we have to place 4 queens. So let me place queen one by one. So what I will do, first I will try to place queen in the first column. Alright, I will try to place queen in the first column. So in the first column, this is column number 0. If I take the 0th base indexing, so if I placed the queen in the first column, so I have 4 options. Either I can place at row number 1, row number 2, row number 3, row number 4. So what I will do, I will try all the possibilities. So here we can see that if I first of all I will try to place queen here, and if I place this queen here, so I should make it separate also, that if I place the queen here, alright, so what will happen, I can see that my queen will be here. Next, or what I can do, I can place my queen here, alright, or I can place my queen here, or I can place my queen either here or here. Alright, so in the first column, if I place first queen in my, if I think of placing queen in the column number 0, that is the first column, I have 4 options, that is row number 0, row number, I should write here also, either row number 0, if I take the 0th based indexing, row number 1, row number 2, row number 3. So I will check that can I place a queen in row number 0. So we all know the property of queen, that we can place a queen here only if this cell is safe, this cell is safe. So we can see that no queen is attacking. If I place here a queen, it is safe because this is not in attack range of any other queen. So yes, we can place here, and similarly here also we can place here also. Now what I will do, I will explore further. Now I have placed my queen, I have successfully placed my queen in column 1. Now where other queen will be placed? Now my turn is to place queen number 2. We have n queens, we have placed one. Now I have now where I can place the another queen? Definitely I have to place another queen in column number 2, because now I have placed queen in column number 1. Now I have to place another queen in the second column. This will be 1th index. So now I will try all the possibilities to place the queen. So we can see here, if I go to check again I have 4 options to either to place here, here or here. So I can see that I cannot place here. If I check this cell, that is this place safe, it is not safe because it will be attacking, so I cannot save. So what I can do, that if my row is, let's say, 0, what I can do, I have to check, obviously if I'm placing here, I have to either check in the left direction, is there any queen, or in the upper diagonal, is there any queen, or in the lower diagonal, is there any queen. So here also there is no queen, here also there is one queen, so we cannot place. So I will not place the queen, I will just return. Now another case, can I place this queen in the row number 1? So here also we can see that no, we cannot place, because if I am standing here, the upper diagonal, in the upper diagonal a queen is placed. So we can just explore by going to direction, by going towards the upper diagonal direction. So we can see that we cannot place here also. Another option, can I place this queen at row number 2? Can I place this queen here? Can I place this queen here? Yes, I can place this queen here because this is safe. So if I place this queen here and I rub these two unnecessary branches so that I should have some space. So if I place the queen here and then what I will get? I will place this queen here. Another option I can find here, that this was row is equals to 2. Another option I can find to place queen in the last row. I can place here because this is safe. So if I place queen here, I can say that I can easily place this queen here also. All right, I have placed. Now what I will do, I have placed this queen here. Now if I have filled these two columns, I will go and check for the column number, the third column I will check, the second index column. Now again I will just explore all the paths. Can I place here? No, because in the left straight direction there is a queen. I cannot place here. So I will say that I cannot place here. Now in the next row, that is row number 1, that is row 1 means the index. So can I place here? So no, I cannot place here because in the diagonally down direction I can find a queen. So I cannot place here any queen. Now in the, can I place here? No, I cannot place here because in the diagonally left direction I have a queen. Can I place here? No, because in the diagonally up direction there is a queen. I cannot place here. So I am just checking the diagonally up, diagonally left or diagonally down direction. Alright, so I cannot place here. So I will not, this will be wasted. So now I will check another possibility. If I place the queen here and if I explore this path, so again, can I place queen here? No, queen is this is not safe. Can I place here? Yes, I can place here because this is safe. So I can place here a queen. So I will say that in row number 1 is index, so I can place here. So I will simply say that yes, place a queen. So previously 2 queens were here and now 1 queen comes here. Now this way, no, this is not safe. This is also not safe. Now again, what I will do, I am done with filling column number, this column I have filled. Now I will go for the last column and again I will check all the paths. Can I place here? No. 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 So this will return nothing because we cannot place all the queens. So this board is not successful. All right. So I will return from here. Again I will return from here, and then I will reach here. So initially these were filled with dots. So while returning, we will also while returning we can easily, let's say I've returned here and now I've reached here. So while returning I can just undo the operations that I have filled the queens. Now I will remove the queens so that when I reach here and I find that there is no possible boards forming, so I will remove this queen and this will return a empty board. Then I can try filling the queen in the next board. So I have to undo the operations also, that you already know. Now these all are wasted. So now for making space I am deleting everything because this is wasted. So now I am deleting these things. Now I will check for this path. This is now wasted. Now I will try to place queen here. So can I place here? No, I cannot place here. Can I place here? I cannot place here. Can I place here? I cannot place here. Can I place here? Yes, I can place here. So I will place here. So if I place here, I should just select this and move here. So if I place here, so I can see that I can place a queen here. So now I found a way. Again, I will try to fill the queen here in the third column. So if I try to fill the queen in third column, can I place here? Yes, I can place here. I can place here. So I will just copy the previous one, and if I try to place queen here, I will be able to place 3 queens. And next can I place here? No. Can I place here? No. Can I place here? No. So this will be only one path. Now again, if I try to go for the last column, can I place here? But wait a minute, this yes, this was at the second place. So can I place the queen here? No. Can I place the queen here? No. Can I place the queen here? Yes, we can place the queen here. So I will say that I can place a queen here. So my one queen can be placed here. And now further, can I place here? No. So now we can see that now I have to fill here. Column is now out of bound. We can see that whenever my column is out of bound, that is greater than or equal to n, that is equal to n, let's say, because whenever it is out of bound, we will say that we have found a bold and we have successfully filled the bold also. These empty will be, we will initialize the bold with empty strings, with dot strings. Now we can see that our bold is now filled, and I will store this bold into a data structure, that is vector. So now I will store this bold. So I have found one. So now again, yes, I will store this. Now when I will return, so now I will be, when I will return, I will be at this position. I will explore this board also. Now doing doing the same things, we can find that we cannot place here. Sorry, we can place here. We can place here, and we cannot place here. Not here. Not here. So again, we will get just the same thing, that I can place a queen here and here. Now again I will try to fill the column number 3, and I cannot place here, not here, not here, but yes here. So we can see that we can place a queen here. Now again, if I try for the last column, we cannot place here. Yes, we can place here. We cannot place here. We cannot place here. So at last, we will see that we are able to place the 4 queens now, and now my column will be out of bound. So we have found 2 answers. We can see that we have found these 2 answers, this bold and this bold. These are our successful boards where we can place the n queens safely. Now again, when I will return, I will reach at this condition. Can I place here? Yes, I can place here. Can I place here? Yes, I can place here. Can I place here? No, I cannot. No, I cannot. So I will explore 2 possibilities, that first of all I will try to place here, and then I will try to place here. So if I try to place the queen here, and if I try to place the queen here, again when I will try to fill this column, so can I place here? No. Can I place here? No. Can I place here? Yes. Can I place here? No. So this will give one possible answer, possible uh, bold. So I should fill it also here, here, and here. Now can I fill this queen? No, 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 and no. So this will return nothing. Now moving here, can I place here? No, 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 and no. So here we can see that we are not able to place any queen. So if I am not able to place any queen, so obviously we can say that we have to return. All right. So we can see that we are getting just two solutions. So here we will just store them into data structure and we will return. So now the logic was just filling the n queens systematically, and if I try to implement this, so n is given. What I was doing, first of all, I have to store this is into a vector of strings. All right, and let's say this I am storing as result. And now initially when I will create boards, this will be filled with empty strings. So boards are what? Vector of strings. Let's say BOARD board, and these every boards are of size n, and these are strings, and every string, a board is of size n, and inside every board a string is representing the row, and every row is of size n, and I will fill every row with dot, because in the question it is said that fill the empty cells with dot and queens with q. Now what I will do, I will just call a recursive function to fill my resultant board, to fill my boards. So first of all I will start from the column number 0, and I will also pass the BOARD board and the resultant. Alright, and I will also pass the size n. Now I want to tell you that when we have to check whether we can place a queen or not. Can I place a queen here or not? How we check? We go to above diagonal, or the left direction, or the direction towards the lower diagonal. So this will take big O of 3n time complexity extra, because first of all we are trying to explore all the possibilities, and inside it we have to check also. So this will take complexity of big O of 3n extra. But what if for the left direction, for checking in the left direction, we create a, what do we say, hash array. Let's say we create a hash array of size n, and whenever we place a queen, let's say initially it is empty, and whenever we place a queen we mark it as 1. All right, we mark it as 1. All right, so whenever we can ask here that is this 0? If it is 0, uh, we can place it, and after placing it we can mark it as 1. All right, and while returning we undo the operations. So again we will mark this as 0 when I will try explore the other possibilities after returning from here and going here. So for the left direction we can create a hash array, and for the upper diagonal we can also create a hash array. So here we can see for creating the upper diagonal. So for creating the upper diagonal we can use a trick of n plus row minus column. So n plus row minus column, this will tell us that whether there is a queen in that diagonal or not. Because let's say let's say we are we have this if I explain this to the diagonal, so let's say indexes are 0 1 2 3 and 0 1 2 3. Now we can see here that if let's say a queen is placed here and I will mark this as 1, and if I want to place a queen here, I will check that whether I can place it here or not. So I need to go and check in this direction. So instead of this direction, I will just simply check n plus row minus column. This n plus column minus row, because I will tell you n plus column minus row. Here is column is 3 and row number is also 3. So this is 0 and plus n because whenever column minus row is negative, so in the hash array we don't have negative index are starting from 0, so we add a n, that's why. So we can see here 3 minus 3 is 0 plus n, that is 4. So we can just simply check hash of 4. So simply in the hash of 4 we will find 1, because why? Because initially we have filled this queen here. Now if I take the, let's say, upper diagonal I was explaining, so let's say this is upper diagonal and I will take this of size 2n, because column minus row can be maximum n and this n is n, so 2n size can be there. So if I fill a queen here, I will fill n plus column minus row as 1. So column minus row is 0 plus n is 4. 0 minus 0 plus n, that is 4. So this will 4. So now I will fill the fourth index with 1, and whenever I am at this index, I can simply do column minus row. This will give 0 and plus 4. This will tell the exactly same unit or same number. This will give 4 of the diagonals. Alright, so for diagonals, column minus row plus n will give the same uh, marking number, we can say. So this is also giving 4 and here it is also 4. So we can find here in the upper diagonal array that this is 4, so we cannot fill here. And similarly for the lower diagonal, we can find here by just column plus row. How? We can see that let's say I want to fill a, let's say a queen is filled here and I want to check here. So instead of going to the lower diagonal direction, I can again create a, let's say, 2n size lower diagonal array, and I can fill, when I filled this queen, so row plus column is 3 plus 0 is 3. So I will fill here the third index with 1. So if I'm here and I want to check in the lower diagonal, I will just do row plus column, that is 3 plus 0. This will give 3, and I will find in the index 3. So this is just the trick to uh, check for the diagonal elements. For the upper diagonal, I will find n plus column minus row, and for the lower diagonal, I can just do column plus row. So we will create these arrays also for checking that is the cell safe or not. So I will create 3 arrays. That for the left direction, I will create left row, and this will be of size n, and for the upper diagonal, let's say upper D, so and here also I'm taking upper left R because it is matching. Now I'm taking this of size 2n. If you want to take exact size, that if I'm doing column minus row, maximum column can be n minus 1, maximum row can be n minus 1. So this can be at max it can come, let's say column, let's say, is n minus 1 and row is 0. So at max it can come n minus 1 plus this n, that is 2n minus 1. But 2n is good. Alright, we can also, the size of the upper diagonal and lower diagonal, we can take 2n minus 1 also. But here I'm taking the round off, that is 2n. So this is 2n, and I want to fill this with 0 also. So I will initially fill them with 0. Now for the lower diagonal also I'm taking 2n size. We can also say take 2n minus 1 size for the exact mathematical calculations, but no problem, we can solve this problem also. Now I have called already the solve function, and after in the solve function I will also pass left R, upper D and lower D. Now I will, after filling my bolts, I will return the result, and now I have to just write the solve function. So in the solve function I was passing so many things. First was the column, then the bold I was passing. So after bold I was passing the resultant data structure, then I was passing integer n, then I was passing the left R array, then I was passing the upper diagonal array, then I was passing the lower diagonal array. And never forget to pass them by reference. This will save time complexity. This will not create extra copies. So now I have to just write the function. So what was the base case? So if my column here, we can see that here my column, I was starting from 0, then it will go up to the last, and when it will go out of bound, we can definitely be sure that we have found our bold. So I can simply push back my bold. Alright, and I can simply return. Now the main thing, that at every column what I was doing, I was trying every possibilities. I can place the queen at row number 0 or 1 or 2 or 3. So I will use a for loop. So let's say row starting from 0, and this row will go up to the last, and plus plus row. And now every time I was first of all checking that whether I can place this queen at this current row or not. So just simply I have to check if in all 3 directions I am safe, I will place. So in the first I will check for the left direction. If left R, that is the array, in the left R row it is 0, and in the upper diagonal I have to check for column minus row if it is 0, and in the lower diagonal I have to just simply check for column plus row. If this is 0, I can simply say that yes, fill the queen. So I will say that fill the queen. Alright, so I will say that BOARD bold of that, fill that cell with queen. So this I will fill this with Q, and now I will move further. So there, if I filled one queen, then I will go and try for the another columns. So I will call column plus 1, and what was I was passing? Bold I was passing, then resultant I was passing, then n I was passing, left r, upper diagonal, lower diagonal, and yes, before passing them I should mark the cell as visited. So left r of row is 1 now, and upper diagonal also I should copy them directly. It is also now 1, and similarly the lower diagonal I should also say that this is 1 now. And while backtracking I have to undo the operations, so I will just say that now make it again dot, and make it again 0, make it again 0, make it again 0. So now we can see we are done now, and let's submit it and check whether we have not made if we haven't made any mistakes. So yes, we haven't tell what to return, we have to return nothing. So now let's check the sample test cases if we haven't done any mistakes. So it is accepted. Now if I submit this and check if we are able to pass all the test cases or not. So yes, we are able to pass all the test cases, and we have solved this problem successfully now. And now if I tell you the time and space complexity, so we can see that after filling a queen here, so for every column I have if n is 4, so for every column I have n options to fill queen either here, here or here. Then if I place the queen here, then in the another column I have the option to, I have 3 options left. Alright, so now at another columns we now have 1 queen lesser, and at the last 1 queen lesser. So we can see that in the first column we have options to fill we have around let's say for this question only we have 4 queens. Alright, so here we can fill a queen. Alright, of those 4 queens we can place a queen here, and then in the next we can place a queen here anywhere in this column. Now again if we fill 2 queens, we will be left with 1 queen. So we can see that in the first column we have 4 options, in the next we have 3, in the next we have 2, in the next we have 1, because we are placing queens after visiting all the columns. So we can see that it will be around we will be checking all the possibilities also. So for placing n queens in this column we have total 4 n queens, so either we can place any queen in the first column. So freedom of n allowed queens. In the next one coin is placed, so in the next column I have n minus 1 coins option, in the next I have n minus 2 coins option. So this will be time complexity of n factorial, and we can see that we are pushing back also after we are reaching the base case. So we have to push this n square bold into the resultant data structure. So if I write the time and space complexity here, so time complexity here will be big O of n factorial plus, for exploring all the possibilities, plus let's say there are possible x boards we have found, x possible boards we have found. So pushing back those x boards will take big O of n square time complexity into the data structure. And space complexity, we can see that we are creating this resultant vector of boards. So here we can see that it is storing the boards of n square size, and if I have total x boards, so we can see that time complexity will be x into big O of n, x into n square. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.